Okay, so now we're going to look at the polar and parametric 5 and 1. I have not graded this yet, so I'm not sure how well you did on it. Looking at it, it seemed pretty easy. So let's just kind of go through this quickly. What are the values of t such that the graph of the curve has a vertical tangent only? So if it has a vertical tangent, then that means dy dx is undefined, or dx dt is equal to 0. So finding dy dx is going to give me the derivative of y, which is 2t, over the derivative of x, which is 3t squared minus 12t, if my math is correct. Okay, so when will it have a vertical tangent only? So when is this 0? So we can do 3t, and that's t minus 4. So this is t equals 0 and t equals 4. However, we notice that when t equals 0, that becomes a whole because the numerator is also 0. So our answer then is only t equals 4. Okay, so they want to know what was the original function if this is the arc length. Well, what we have to remember is that this was 1 plus f prime of x squared. So f prime of x is the square root of 4 over x squared, which is 2 over x. Then to find f of x, we have to integrate 2 over x, which is the natural log. If I integrate that, I get 2 natural log of x, which can be written as natural log of x squared. Okay? Number 3, hopefully we can do that by now. I don't have the formula in front of me, but you need to memorize that formula. The answer was D. When I do this, I just do it the long way. I know that x is equal to r cosine theta. So in that case, it's going to be 3 over theta times cosine theta. And y is going to be 3 over theta sine theta. So then what I would do is I would do dy d theta over dx d theta. That's what I would do. And of course, I'd have to use product rule for that. But so dy d theta is equal to the derivative of dy d theta using quotient rule. This is theta to the negative 1. So that is negative 3 theta to the negative 2 times sine theta plus 3 over theta times cosine theta. And then dx d theta is negative 3 theta to the negative 2 cosine theta plus 3 over theta sine theta. And then you just plug and chug. So we're doing pi over 2. So that's negative 3 over pi squared over 4 times the sine of pi over 2, which is, sine of pi over 2 is 1, plus 3 over pi over 4, and cosine of pi over 2 is 0. And again, cosine of pi over 2, so that's going to be 0. And then this is going to be 1 over 3 pi over 4 times 1. So the 3's cancel out and blah, blah, blah. You end up with, oh, this should be pi over 2. Those are pi over 2's. So you end up with D, 2 over pi. Have fun with that. Okay. The position of the particle, and which of the following is the particle at rest? The particle is at rest when both the x component and the y component are both 0. So dx dt is equal to 3t squared minus 6t. So 3t factored out, we get t minus 2. So it's 0 at t equals 0 and t equals 2. So y of t, dy dt, is equal to 12 minus 6t. So t is equal to 2. So we have t is equal to 2, but our coordinates are in terms of x and y, so I need to figure out what x and y are when t is 2. So x of 2 is 8 minus 4, 12, so negative 4. So I'm thinking the answer is A, and then I could check it with the y of t, okay? I think problem number 5, I was told after class that this one has a mistake. Let's see, it does, I can see already. So 2t over 2t, which is 1, so that's dy dt, that is dy dx. And then when I take the derivative of that, it would be 0 over 2t, which is still 0. So there's a mistake on that, and I don't know why it says C, but there's a mistake, so that will not count against you, but we had 6 on here, so you just have an extra one. Which of the following gives the length of the parametric? So because it's parametric, we have to use the formula, the integral from 0 to 1 of x prime of t squared plus y prime of t squared. Okay? So x is going to be, that's going to be 9. So x prime is 3. So that's 9. I know I skipped some stuff there, but I did it in my head. So x prime of t is equal to 3. Y prime of t is equal to 2t. So that's going to be 9 plus 4t squared. So 9 times 4t squared from 0 to 1 is d. Okie dokie, that was pretty simple. I have not graded your 5 and 1 on that one yet, but I will, and hopefully everyone did well on that. Okay, again, have a good afternoon, and I will do the free response in just a second.